Welcome to Big Data and Brews, today with E14 or Eric Baldeschwieler. Welcome.
Oh, thank you.
Can you introduce yourself and a nice cold drink you brought with you?
Sure. I'm Eric Baldeschwieler. I've been working with Hadoop since its inception. And before that, I was building search engines for Yahoo and Inktomi. So I've been working with big data since '96 by some reckoning.
So he was at Inktomi before, and joined the team with the, I think, acquisition, right?
That's right. Inktomi was acquired by Yahoo in 2003. So, and the beer.
Yeah.
Well, this was in my fridge.
No, both Germans, you know.
That's right. So there's a cultural heritage, a shared cultural heritage here. So this is actually California beer. There's a lot of great beer in California.
I do agree.
This one is from I'm having a senior moment. It's from the south of us near San Luis Obispo, Paso Robles. So yeah.
So a microbrewery.
And I found it in my fridge. So nice. I actually drink it fairly regularly, obviously.
Okay, well then let's do it.
All right.
So the first question that I, when we hang out somewhere at one of those events, when people meet you, is like, why E14? So what's the background there? Yeah, that was your email address at Yahoo, I assume?
Eric14 is a label that's been with me for a long time. It actually goes all the way back to my sister's grade school, where there were two Karen B's. And so there was a Karen 6 and a Karen 14, because Baldeschwieler has 14 letters in it. Okay. And so when I had to choose an email address in college, it seemed the obvious choice.
It's very obvious. So let's see. So that's two different kinds. So I have a double barrel ale.
I think it's the same beer with two labels.
Oh, okay, good. Just mixing it up. It has 5% alcohol, so okay.
So we can't be held responsible for what comes next.
Yeah, we just talk about technology, right?
That's right.
Well, cheers. Thanks for coming.
Prost.
Yeah, that's a good strong beer.
It's
not one of those American beers that comes in a can and is brewed from maybe corn or something. Yeah.
No,
rice.
I have this hypothesis that they never stopped brewing beer in California during Prohibition.
Yeah.
If you go out of the cities, there's all these really good microbreweries. Yeah. So I think they just never stopped.
They just yeah, that makes sense. Well, so help me a little bit with your history. I mean, what did you do maybe before Inktomi, and how did your career go there? And then I guess most famously you known to run the Yahoo Hadoop team and really build this up there. So help us to get there, and like from a technology perspective.
All right. Well, so I mean, I came to the Valley, '87, from Carnegie Mellon. Worked at a video startup called Digital FX. So built lots of systems. And then went off to school, came back, worked at Electronic Arts on video games.
Oh, cool. I didn't know that.
That was fun.
Yeah.
So we made a flying game on the 3DO, which was a platform that was very interesting for a short period of time.
And it's all hardcore C++. Yeah, the good old stuff.
That's right, trying to figure out. It's fun. The fun thing about those applications was that you really had to figure out how to use the entire machine. Your app didn't fit comfortably in the amount of memory, and the amount of storage, and the amount of CPU you had. So you really had to understand the machine. And that's one of the things I really, to this day, look for when I hire people for this kind of work, is you want people who haven't just written in Java or written in C, just plugged things together. You want people who've had to struggle with something that doesn't fit in the size, in the amount of resources they have, and have had to really learn how to program as a result.
Yeah. So. One of my favorite papers is why you as a Java developer should learn assembly. Did you ever read this thing?
No.
So
it makes sense to me.
Right. To really understand, the whole hops and switches and memory management and all that kind of fun stuff. It's a really interesting paper. And I mean, basically say, well, you don't need to write everything in assembly, but if you really understand the concepts there, then a lot of stuff, including garbage collection and what have you, really makes sense. But yeah.
Yeah, it's always fun to just ask people, how does a function call, how is it implemented?
Right.
Or how does garbage collection work?
Right.
Right. And if you're not ready to work on system infrastructure if you don't understand those things.
Yeah. Okay. So the flight simulator, and then
then back to then I hitchhiked around Europe for a couple of years.
Oh, that's cool.
Yeah,
a couple of years even.
Yeah. So,
what was your, beside Germany, of course? What was your favorite?
Well, so I'm actually, my grandparents are Swiss. So,
okay.
So I actually managed to get a job at the ETH in Zurich.
Oh, cool.
So that was
beautiful
a
city.
home base. And not only is it a beautiful city, but you can take the train in an hour and you can be in Italy, France, Germany. The world changes very quickly from there. So it was a great place to explore Europe from. So did that. And then back to Berkeley for a couple of years, and then into Inktomi.
Okay.
Which was just an amazing time to be looking for a job, of course, because the .com thing was just really starting.
Yeah.
And Eric Brewer, who was one of the founders of Inktomi, was my advisor. So I looked at a number of other places, but ultimately I decided I'd be nuts not to join this thing.
Right.
So really it was at the beginning of a sort of search engine revolution that happened throughout the .com era. And so Inktomi kind of is one of these companies that was huge and then got very small near the end.
Yeah.
But throughout that period, we were just building and rebuilding the search engine. And my part of it was actually building the content system. How do you crawl every document in the world and tear it apart and index it so that it can be found by the runtime search engine? So that's building a big data system if you think about it. And so I ran a team from 97 to 2005, both at Inktomi and then after the acquisition at Yahoo that did that. And by the end, we liked the marketing number was we had 100 billion document crawl. Probably more carefully, we knew of 100 billion URLs.
Right.
That was how Google was putting it, so we did the same thing.
Right.
So we were crawling tens of billions of documents and managing, 100 terabyte data sets, things of that sort, which back in 2003, 4, 5 were really big numbers.
Yeah, definitely. Did you, what do you mean with the content system? Was that part of the crawling or the post-processing?
All of that. So discovering and fetching every document in the web, i.e. crawling it. And then, now you have a pile of tens of billions of documents. How do you turn that into something the search engine can use? So that means building a web map so you can do page rank and all those things. So taking every document, tearing it apart into sets of terms, and then sorting all that information by the terms, sorting it by the document that a link is referring to. So basically doing, petabyte scale sorts. So we built a series of infrastructures to do that, and just storing and managing all that data. So we rebuilt and rebuilt that system about 4 times by 2005.
Wow.
And then in 2005, actually what happened was we were thinking about re-architecting it again. And the science team started coming and banging on our door saying, he didn't stop at my door. They were giving me a lot of advice. That they would love to have a system like these papers they were reading from Google, because they wanted to do research on all the documents that we were crawling, and we built these 1,000 computer clusters to do one of them to crawl the web, one of them to do this sort of page rank calculations, one of them to actually build the final indexes that the search engine used. But all of that hardware was dedicated to that one purpose, and they couldn't use it.
Yeah.
So we were looking to re-architect all that anyway. So we said, well, that was at the point where we said, let's build a system based on the MapReduce interfaces and the HDFS interfaces. The Google file system interfaces. We knew we could do it because we built 4 of these before. We already had a 1,000-node system that was effectively running MapReduce. Right. But the APIs suggested by the Google guys were better. Yeah. And we looked at that and said, okay, if we rebuild it this way, then we'll be able to reuse that software in many more applications.
Right. Before we go into more of that really cool infrastructure, I want to double click a little bit on that challenges you had around search engine, because I worked in that area as well, and it was always like, boy, how do you get to such a big crawl, right? So, and there's all those little tricks, and, HTTP keep alive, and, DNS caching was a really big problem for us, especially in the nudge days, because we basically didn't go to one host and downloaded all the documents, but we took URL by URL. So we had to do a DNS lookup for every URL we had to, it didn't go to cache. So how did you guys manage to crawl that much data? I mean,
well, some of those problems get easier at scale. Some of them get harder, right? So you would partition the crawl by host.
Okay.
So things like DNS caching were not a big deal.
Right.
But you obviously do need to do it. But the biggest problem we had was being nice to the world.
Yeah.
Right? Because I learned a lesson back in around 99 when one of my engineers running a test crawl on his laptop took down Microsoft. Right?
That was you?
No, it's just one, but you think about it, how many websites, especially back then, were prepared to have, somebody open up and start to fetch thousands and thousands of pages simultaneously. Right. They just weren't architected for it. Today, I don't think you could take down Microsoft from your laptop by just asking for its pages.
Right.
But back then, you could take down any site in the world that way.
Right.
Right. And so, just figuring out how to be polite. And then you'd have the reverse problem, which is,
not fast enough.
I need to get I need to get millions and millions of pages out of this website. How do I sequence that? So there's a lot of tricks. You partition it where you could, then you had to keep a list of active hosts. The other one that really was a pain was...
And active host means open connections, or...?
Yeah, well, you had to keep a list of the hosts that were big enough that you couldn't just take by default, you just take all the URLs and randomize them, and you're done. Right? Okay. That's a strategy that Nutch probably used.
Right.
Hash by the URL.
But then we had the DNS lookup problem that slowed us down.
Which, there's that problem, and there's the problem that some hosts are just too big for that, and you're still going to violate politeness if you do that. So for those big hosts, you'd need to come up with a strategy.
Yeah.
Right. And, so some of them are just like Yahoo. They have a lot of pages. But what really got us in trouble were things like affiliate networks. Like if you look at Amazon, they keep your cookie in the URL. And that means that you can crawl the whole site as a unique site per URL in the world, or they'll just dish you out a new one every time you visit.
Right.
Right. So when we'd go back and look at the crawl logs and realize that, my gosh, we have 1 billion pages from one website. What is going on? And then we'd have to go back and figure out rules. And you could just ban the site. That was the first solution. But, there's better solutions.
And did you build a cookie management system?
We did a little bit of that. After I moved off to the Hadoop project, they got very sophisticated, and they actually built a crawler that used Mozilla as its core.
Oh, okay.
So they were building the whole page,
to execute the JavaScript.
Oh,
cool.
Because, again, in the early days, a page was a page.
Right.
But at this point, what is a page?
Right.
Unless you can... is it Flash? Is it who knows what, right? So there's just rendering it out so you can understand what a human is seeing gets to be a hard problem.
Well, now I know why Chrome is that high up on the whole stats for the browsers, because Google is just using Chrome up now. So I'm sorry I interrupted you. You was going into more of the infrastructure side before I sidetracked you with all that cool search engine stuff.
So that was a fun journey, of course. But so by 2005, we looked at this and it became clear that there was an opportunity to re-architect our system. And we had a number of different problems that we were trying to solve. One was make the data accessible to scientists. One was build a larger scale version of the crawl, right? You always needed to get bigger every year.
Yeah.
And the clustering systems that we had worked at 1,000 nodes, but they were starting to spend more time doing sort of handling error recovery than actually running the code, because as you get to that scale, things fail all the time. And if you're not very clever about how you handle failure, what you think of as an exception case is the dominant case in your code. So we would, every time a node would fail, the system would go down for a few hours to rebuild
Ooh,
and
okay.
so we were failing, nodes were failing frequently, that the system was spending about half its time rebuilding. And that was
Okay.
still okay, but if we doubled it again,
Right.
right, then you wouldn't see any improvement to that size. Not unless you start spending more for your hardware, which you don't want to do,
Right.
Since that was a multi-million-dollar budget as it was. So we were looking at all that, and Hadoop solved that problem. It was clear how it could solve that problem. It had the built-in failure design that was more sophisticated than what we were doing. And we also had this sort of science recruitment problem, which was that to build the best search engine and advertising systems in the world, we needed to hire great people.
Yeah.
And that at that point in time, nobody thought of Yahoo as a place that did big data science.
Yeah.
So we decided, how are we going to put ourselves on the map, right? We could build a different system than what Google has done and publish that design. But, they have more systems researchers and more staff. We're not going to and we'd be a second system. It's not going to get a lot of attention. But if we take, their inspiration and open source it, right, that'll put us in the conversation in a completely different way. So that was kind of a decision that we made as a company, was that we want to actually, put Yahoo on the map by building an open source big data system. And we knew we could do it because we built several. And we started out with the Google papers, and we then actually went through this whole design process of, how are we going to refine this and make it better, put our own touch on it. And we changed and changed and changed. And we got to a point where we had a completely different design than what the Google papers suggested.
Yeah.
And then we looked at that and said, well, what's going to happen? We're going to open source this thing. We want it to be adopted. What's the best guarantee we have of getting it adopted? Well, it's to conform to a familiar template. And these papers are out there. They're a template that everybody understands. So we took the design all the way back down to being very similar. And another thing we decided really early on was if we clone these papers, clone is probably not a word that people would like to hear, but if we use these APIs as our inspiration, then one of two things happens. Either our open source project wins, right? Everyone adopts it, and then there's huge benefit to us because the world is contributing to the infrastructure we use. We get to hire people who already know how to use our infrastructure, et cetera, right? Or we lose. Somebody else builds an even better open source version of these papers, because somebody will.
Yeah.
And then what happens? Well, then we have a very easy job of porting all of our infrastructure to the dominant paradigm, and again we win.
Yeah.
So open sourcing seemed like a really good bet, and conforming to those papers seemed like a really good bet. Although it was interesting, this sort of NIMBYism, not NIMBYism is the wrong word, not invented here, NIH. People, even years after the Hadoop project was just going gangbusters, people would stand up in big town hall meetings in Yahoo and say, I can't believe that Yahoo's not innovating. Yeah. Right? Because Hadoop is just a copy of the Google papers. When are you going to do something original?
Yeah.
It's like, well, great ideas happen elsewhere. I forget who said that. I forget who said that, but it's a Valley quote. Yeah. But if you can't, what's important is not proving that you have a clever idea. What's important is executing.
Right.
And the choice of open sourcing and MapReduce infrastructure did tremendous good to Yahoo, right? In the end, I mean, we managed to hire and retain a great team, even though Yahoo was going through some challenging times, shall we say. But much better than that, we really put Yahoo on the map in terms of hiring scientists. Right. And they built a really world-class science organization that drove a lot of innovation across all of Yahoo. But the story gets to Hadoop actually in another step, which is, having made this decision, we staffed a team out of the people that had built the last 4 crawling systems and started building a prototype called Juggernaut. But then at the same time, Rami Stata, who was at the time the chief architect of search and advertising, he later became the CTO of Yahoo, had hired Doug Cutting. Right? And Doug Cutting had built this prototype of MapReduce and the Google file system in the Nutch system. You were already using it at this
point. Oh yeah, I was working with him since 2003 on that.
That puts you in a very rarefied crowd.
So. One of three, yeah.
But yeah, so you were one of the very few users of Hadoop before it was Hadoop.
Yeah.
But so Ramy started suggesting that I adopt Hadoop as the foundation for this open source system we were going to build. And this was something we discussed and debated for about 6 months before finally I concluded, okay, this makes sense, we're going to do it. And it's funny, we should get back to the Java C++ thing in a second, because that was one of the things. But we were looking at this and going, our design is much better than Doug's implementation, right? We know how to build these systems. We've built 4 of them. Why should we adopt this thing that is really just a prototype?
Right.
Right. But then you looked at it and it's like, okay, it's a prototype, but it's a prototype in Apache.
Right.
Right. And it's built by someone who's built successful open source projects before. And, who can teach us a hell of a lot about that. Right. And so there's this huge jarring transition we made where I took the team that we built to build such a system, threw out our prototype, and adopted Hadoop, and then started the process of understanding it and refining it.
So before we go into more of that history of Hadoop at Yahoo, and I certainly want to know more about the whole C++ and Java discussion. I'm sure that will be fun. We will make a break, have a few more beers, and then
a few more beers
in between, so we can go
singing when we come back.
Exactly. Well, that's the idea. I want to hear all the songs about all the interesting things that happen behind the curtain, and we will be right back.
All right.